Hello, my name is Richard Halter. I'm the president of Global Retail Technology Advisors, and what you're about to see is a presentation I made on robots generated data in retail. This presentation was given at the Retail Analytics Council as a part of the Robot Research Project in October of 2019 at Northwestern University. As a part of the presentation, I've added videos from the various vendors, but I had to shorten them in order to fit the time frame. This is an outline of the various use cases that are going to be covered in this presentation. As you can see, there's one on pick, pack, deliver customer orders. There's an audit shelf use case, autonomous floor cleaner, a spill hazard use case, a delivery management use case, a warehouse pick, pack, and ship use case, and picking groceries in the warehouse use case. You can see that it covers quite an extent of the various uses for retail robots. At the top model, this is the business store model. As you can see, there are lines running all over the place. I was chairman of the committee that created this originally, and I have since expanded it dramatically on my own. But as you can see, retail is very complicated. Since this presentation is on robots, we will start at the lowest level, the robot interfaces. These set of interface standards were created under the leadership of the Japanese group and are in the OMG retail inventory. We start with a set of visual standards, being able to capture video, being able to recognize an individual or things within the video, and being able to display video information. But on top of that, we move into the sound area. We have a sound player. We have a sound recorder to be able to record various sounds. Voice recognition, being able to identify people, places, things. And speech synthesis in order to create audio on the fly. We want to be able to monitor the device itself. We want to be able to control it with all sorts of gestures. And there's a whole set of gesture control standard. And then just some control software to move forward, move back, move sideways. So this is our first use case. It's a pick, pack, deliver, customer order use case. And it starts with the things in the house, the IoT devices. You're going to see now a future-looking view of the retail world, starting with IoT devices and ending up with self-driving automobiles. So in the house, your refrigerator decides that you're low on eggs, and it builds out a shopping list. You can add things through Echo into your shopping list, or maybe go to a website and build it out. You send the list to the store. In the store, they have to develop a path through the store to pick the various items. And that's depending on various things like what is your inventory of those items, what are the items, where are they in the store, and what sort of preferences your customer have. You then send the robot around the store to pick up the various items. Once you've got them all, you move to pay for them, which goes into a payment processing component that goes to the bank to get the authorization to pay for the items based on the customer's credit card purchases or preferences. In addition, then, you can also directly pay the taxes on it, going right to the Treasury, rather than having to store them in the store and pay for them on a quarterly basis. You can pay for them as each transaction occurs. Once all of that done, you can start looking at delivery. Are we going to deliver these things with a self-driving car, in which case we need to know where it is. And so we interface with the parking location standard for identifying where the car is. Or we deliver it through a drone vehicle. We tell it where to go deliver the items. And we can even use a drone to deliver them directly. So that's the use case. And now let's look at the various systems that have to interoperate to make that use case work. Well, first we have to have the refrigerator. We have to have the IoT interface to that refrigerator. We got to have a shopping list, and that falls under this POS log schema. POSLOG schema is one of the most popular schemas in the inventory of retail standards. We need an inventory. We need to know where they are. So you've got to have an inventory schema. We have to build a shopping cart. So we have another use for the POSLOG schema. Same here, shopping list comes in, we add in location information and send that off to the robot. Of course, we have to control and drive the robot itself. We have to interface to the payment standard. So there's a payment integration set of schemas. We have to find things. Obviously, there's a location schema in the store. So where in the store is this inventory of items that are on this shopping list? That moves us on to the audit shelf use case. So let's take a quick look at the audit shelf use case process model. So we start with the robot that we were looking at in the video. It's got to be able to travel up and down the aisles. It has to be able to take images and evaluate those images. So he's comparing what is against what should be, if you will. He then has to be able to identify and analyze the information within the image. So is it the correct item? Is it the correct quantity? Is it price compliant? Is it in the right spot? And be able to then notify the proper people about the various discrepancies that it finds. So now let's take a look at the systems that have to interface in order to make a shelf audit robot work. Of course, we have to start with the robot itself. We have to be able to check prices, so we've got to be able to connect to a price book. We have to be able to find things, so we have to be able to deal with the locations of things. We have to be able to check traceability, so in case there's our recalls on particular items, so we need to be able to find those things. We need to be able to evaluate what it is from a picture, which is the product content management work. We have to be able to drive things around. That's the video analytics work. Inventory management, making sure we have the right quantity of the right kinds of items. Item maintenance, of course, is the item detailed information. And wayfinding is what helps with the video analytics to drive you around the store. So now let us look at the autonomous floor cleaner robot and the use cases around it. So as you can see, the autonomous floor cleaner use case is a little simpler than the ones we've been looking at before. Fundamentally, you have to be able to travel up and down the aisles, you have to be able to avoid obstructions, and primarily just clean the floor. In the simplified version, you basically need to interface with 4 different kinds of systems. Of course, the robot itself, you've got to be able to interface with the wayfinding, where things are laid out in the store and how to drive around the store. The location work, to be able to find out where you are with respect to the other items. And the video analytics, to be able to identify and analyze what is in the video feed. So our next use case will cover spill and hazards. So our spill and hazard use case process model shows basically you receive a notification of a spill, or you're traveling through the aisles and you detect the spill, in which case Marty is the robot that you interact with. And if you detect the spill, you either notify an associate about it, or you move the robot to the spill to start doing the cleanup. The associate communicates with people about cleaning the spill. And maybe it's the robot itself that does the cleanup work, or the robot simply stands guard over the spill to make sure nobody gets hurt until an associate can come and clean up the spill, at which point the robot then gets released to start its traveling around looking what's going on. And then it generates some post-incident report. So as you look around, you can see the interfaces or systems that the robot has to be able to interface with. Of course, there's first the robot itself, being able to communicate with it and have it move around. Wayfinding, to be able to move around through the store in some intelligent way. The video analytics schema, to be able to see the videos and analyze any spills that might be found. Of course, the operational data model, in order to be able to record the result of that findings. Content management, to help identify systems and applications and devices and things that are already in the floor or in the system. Planogram, to help you identify, along with the product content management and the wayfinding, what's located where. And then the location schema, just to identify where you are within the store. So that brings us to our next use case, delivery management. So here's the delivery management use case process flow. So basically online, people order stuff, they get picked and packed and put by the robot through the store. You're able to find out where the customer is or where they live. You identify what is the best delivery method for them, whether it is using a drone to be able to deliver the thing, send it in the post office. using the autonomous cars. And I'll have a future video on autonomous cars as I help them define their systems. And finally is the delivery robot is the last option. So in order to do delivery management, you've got to be able to interface to a number of different systems, and you should be able to start seeing some of these things over and over again. Customer information, you got to be able to deal with that. Location, in this case, we've got a worldwide picture rather than a set of aisles. The warehouse, where is it to go pick up that stuff? The parking information, this is for the autonomous cars in order to be able to find where they're parked. And of course, being able to communicate to autonomous cars as well as delivery robots. And that brings us to our next use case, warehouse, pick, pack, and ship use case. In a warehouse, there are a number of different ways of moving robots around the warehouse floor. For example, you can have a rail, it can be a wire guided, you can have them checking on various labels, you can have magnetic tape on the floor to guide them, they can use laser vision to figure out where they're at, video, and being able to guide themselves by their XYZ coordinates. And that's what is indicated by this railroad tie. But in the warehouse area, you've got to receive packages, so they come in the front end. You have to unload those packages, sort them out, transport them to the shelves, store them on the various shelves so that you can get access with them. So you would use these to store them as well as to retrieve them, go along later and pick them depending on the customer's desire. And you want to pick them, of course, in the most efficient manner. And then you want to move them back to the shelves to the various packing stations so they can be packed or shipment to the customer. And finally, you do an audit on them to make sure that you're actually delivering what the customer ordered. And then eventually you do the delivery, either with drones or the mail or drone cars or self-driving cars. This ought to start looking really, really redundant. As you'll start seeing, we're looking at the same sets of systems that you have to interact with in this warehouse pick, pack, and ship model. Again, you've got to deal with the robot itself. You got to be able to identify items and where they are. You've got to get the stocking of where they are actually stocked. You have to be able to guide around the inventory to see, we've got 50 red shirts or whatever. What is the locations of those things to be able to drive around to get them, and then locate them in the stock locator, and finally interfacing with the customer for finding out what the customer desires, first off with their pick list, and being able to pack the items that they prefer. And that brings us to our last use case, picking groceries in a warehouse. that leads us to the picking groceries in a warehouse use case process flow. And this process flow will look very similar to many of the other ones. It'll have a lot of the same kinds of information in them. In this case, you receive a pick list. You generate a route from that based on what's in the store, the layout, where the restrooms are, where the aisles are, etc. And the item, what item are you locating where? You'll generate a route to that item. You'll follow that route. You go around and put items in your shopping cart through the robot interface, and you go around and get the next item until you finish picking all of the items for this customer. You go through the packing of it, and you pack the items out of the robot shopping cart, and you send it off to the loading dock to be shipped to the customer. So that leads us to picking groceries in a warehouse systems interfaces. We start off, of course, with our shopping list from our customer. We generate this pick list using this POLOG schema. We find out where things are with the location and the inventory management schemas. We generate a list of picking where we want to go, and we use the stock locator to find that set of items. We then go to the stocking interfaces to actually pick that one out of that pick list and use the robot for putting it into a box for shipment out to the customer. That brings us to the end of this presentation on the various use cases on using robots in the retail environment. I want to thank the Retail Analytics Council for inviting me to talk. It was a fascinating meeting because it was mostly robot folks in the audience. As you can see from this presentation, there is a lot that has to be done on the retail side to interact with these robots in some intellectual way. In addition, I've just released version 2 of my book, Arts for Retail, Using Technology to Turn Your Consumers into Customers and Make a Profit. It's available on Kindle for download. Thank you. My name is Richard Halter. You can reach out to me at richard.halter@cox.net. Again, thank you.